On this week's MetPy Monday, we'll finish parsing out our aviation weather reports, our pilot reports, and get ready to make a plot. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer at Unidata. On this week's MetPy Monday, we're going to continue the exercise we started last week of parsing out pilot reports from the Aviation Weather Center. Now, one of our eagle-eyed viewers had pointed out that indeed the Aviation Weather Center makes these available as a comma-separated values file, or a CSV file. Now, it would certainly be pretty easy to parse. In fact, it would be one line with something like pandas. This is an exercise more to show us how to do some web scraping. But yes, if you do have a available format like that, tab delimited, comma delimited, XML, JSON, anything like that, it would certainly be more reliable in a production setting. In some cases, though, the only way you can do it is web scraping, and we'll continue with that approach here. So as a reminder of what we did last week, we used URLlib to retrieve the data from this URL, the HTML response, and Beautiful Soup to parse that out. That gave us this thing, table data. And table data was a list, in this case with 928 elements, but yours will be different depending on when you run the script. And that list, each one of those, is an individual HTML table that contains a single pilot report that we need to parse out. So that's where we're going to start today. I'm going to make a variable report HTML, and I'm going to store a single report in it. So now if we look at what's in there, we see it's a single table. There's the raw text, the observed at, aircraft type, location, flight level. In this case, it's a turbulence report. So now we need to parse out that table a little bit more. So I'm going to make a variable report rows, and that is going to be our report HTML. We're going to find all of the table row tags. So now if we look at report rows, it's a list with the first element being the text, the second element being observed at, and so on. So for example, the second index, the third element, is the aircraft type. The next thing we need to do is get the text out of this. So I like to work on problems like this one chunk at a time. Instead of going ahead and writing a loop that solves everything, let's do one piece at a time. So we're going to work on this individual element of report rows first, then we'll go back and generalize it to a loop that runs on the whole report. So we need to get the text out of this. We don't care about the HTML tags. So if we call .getText, we get this string. That looks better. This looks more parsable. The next thing is I want to get rid of the new lines. So I'm going to call strip. Remember, we can chain operators like this until it gets unwieldy. And the next thing we need to do is split this up. This is the data. This is the data descriptor. So we'll use .split. And we don't want to split on a comma. We want to split on a colon. So there we go. Now we have that row split apart into two things, the data descriptor and the data. Now you could shove these data into a lot of different data structures. You could have a list of lists where each list is a report, and then you have a list containing all of those. You could use a pandas data frame, which would actually be not a bad choice, but I want to show some other language features today. Or I think really one of the more versatile data structures for this would be a dictionary, which pandas data frames are fancy dictionaries. So we're going to make a dictionary where the key is the data descriptor and the value is the data. So each report will be a dictionary. And then we'll put all of those dictionaries into a list. So we'll have a list of dictionaries. So now that we know sort of how to parse these reports out, let's go ahead and write a little loop that will work on one report. So I'm going to create an empty dictionary to store the report data. And we're going to go for row in report rows. I'm going to reuse my variable name row, and it was row.getText.strip.split. So that will get us to this point. And now we need to shove that data into a dictionary. In this case, I'm going to call report our dictionary. I'm going to use the update method. I think this is a little bit cleaner syntax-wise, but certainly you could use square bracket notation if you wanted. And then we're going to pass it a dictionary, with the first thing being our key, which is the 0th thing here. So row 0. The second thing being our value, which is row 1. So let's try that and see what happens. If we look at what's in report, this isn't bad for a first cut at it. So we've got the raw text, observed at, aircraft type, location, flight level, and then any other turbulence or other reports. So this is pretty useful already. One thing that I'd really like to see different in here is the location. Right now, location is a string that's latitude and longitude, and I would rather have a latitude key as a float and a longitude key as a float. You could go on and do this at the observed at and flight level. You could make several special cases here, but for plotting on a map, turbulence reports, all I really need is the location and the turbulence fields to be useful for me. So let's go back up here and modify our little loop. So if this is the location field, split it apart. So if row 0, that thing that we're going to use as the key, is location, I'm going to make a variable location. I'm going to say it's equal to the value, and we're going to split it on commas. So we're splitting this apart. And then we're going to shove each of those latitude and longitude things into our dictionary. Now this is going to have some pretty condensed syntax here, so follow it through and break it down step by step if you need to. Report.update. I want to have a key latitude, and I want its value to be location, and it's going to be the first thing in there, so it's location 0. But that gives me the string 31.2651 latitude, and I don't want all of that. So I'm going to use .replace to replace latitude. Actually, I want to replace space latitude because I don't care about this space either, with an empty string. So that's going to get rid of all of that text. And then I need this to be a floating point. I need it to be something numerical that I can plot. So I'm going to wrap it in float to cast that to a float. So to recap, we're going to put a new key in our report, latitude. It's going to take the location row, split on a comma. The 0th thing will be this substring. We're going to replace space latitude with the empty string. So we just have this string, and then we cast it to a float. And we need to do the same thing with the longitude. So in this case, we'll copy and paste. Longitude, this will be the 1th thing, and we want to replace space longitude. So that's if this is the location. If it's not the location, we want to do what we were doing before. So we'll use else. So now let's try that. We run the cell. Now we look at our report, and we see we have latitude as a floating point, longitude as a floating point. So now we've successfully parsed out the text of the report that we're going to find useful. So now we need to do that for every report in our data table, which was over 900. If we're going to do something a lot like that, it sure sounds like we should have a function. So what we need to do is make this whole mess a function. So instead of modifying that cell, we're going to copy and paste here and try to avoid some more out-of-order execution things in our notebook. We start out functions with def. I'm going to call this one parse report, and it's going to take report HTML. I'm going to paste. We indent, and we need to return a result from the function. We're going to return the report. So to recap, we're taking a single positional argument, report HTML. We're going to do all of these things we just did to it, and then return the dictionary report that we created from this function. So now we need to apply that to everything that was in our table. If we scroll back up, table data is the name of all of our list of every table element. So I'm going to use a list comprehension to do this. I think that's the most concise way. So I'm going to say reports equals, and if you're not familiar with list comprehensions, you might want to go back and watch our MetPy Monday on them. So the first thing in the list comprehension is going to be what we want to store, which is the result of our parse report function. I'm going to pass a report to it. For report in table data. So for every item in our table data list, we're going to pass it to parse report and add that result to a list that we're going to call reports. We run that cell. You see it ran pretty much instantaneously. And now if we look at reports, it's a list of dictionaries. If we look at a single element of it, it's a dictionary. And then we could access an individual element of that dictionary, such as latitude. So you should see that we're really pretty close to getting our plot made. The only things we need to do is now go and pull out each latitude and longitude and the turbulence report, if there is one, from all of these reports and put it on a map. And we need to do something about the turbulence reports because they have all kinds of things like light chop, light moderate chop, severe chop. We need to make some kind of grammar parser there. So we'll do that next week, parse out that data, and get it on a map. Thank you for joining me on this week's MetPy Monday.